Well, good afternoon, everybody. Welcome, and I will do my best to keep you awake here. This is kind of a dry subject. Might as well lunch right into it. I'm not going to go over any more of what about me. So that was John. Thank you very much for that introduction. We are, just for clarity, we're not going to talk about the zirconium technology or thin film technology per se. We're going to talk about when you have to convert your old zinc phosphate system to a zirconium system. Now, first of all, I see a lot of familiar faces that I have been out in the field with converting systems. But how many people are familiar with pretreatment? Just a show of hands. Great. How many people are familiar with zinc phosphate? Beautiful. Zirconium? Oh, God, this is going to be great. Okay. All right. Well, I'm not going to spend much time there. I had one introductory slide on pretreatment. I'm really not even going to go there because of looks like the experience level in the room. But just a quick background on zinc phosphate and zirconium. Really, zinc phosphate's been the benchmark for many, many years in OEM pretreatment technology. It's a very robust, tried and true process. And over the years, incremental performance improvements with different, ions that are used. I mean, there was at one point it was dicationic, now it's tricationic, and improvements in the surface conditioner have even boosted the already excellent performance. As far as zirconium goes, it also has excellent performance, and it has really become the choice for most OEMs. There's a few OEMs that still have not stuck their toe in the water of zirconium, but they're moving fairly quickly to do that. It is certainly a much more green technology, very, very sustainable compared to zinc phosphate, and lower operating costs. For those of you who are using it, that's very clear at this point. Quick slide on the market. I mean, you can really see zirconium was first introduced to the OEM pretreatment market by us with Ford. In 2007, the first introduction at the Ford Twin Cities plant, which unfortunately is no longer there. So the technology's been around for a while. This is what, 2025? It's been there 18 years, but it was very slow to take off. Zinc phosphate had been around for a long time. People were more comfortable with that. So it's really been in about the last 5 to 6 years that zirconium has really, really taken off, and the projections continue to rise every year. I could speak for hours on this subject. So this is a big topic, and we've only got a short amount of time, but I do want to make this as interactive as possible. If you do have a question, raise your hand, because it's important you get it asked when you can think of it, not necessarily wait to the end. So let's start with a typical OEM zinc phosphate system. This may not look exactly like yours, but it's kind of a generic version. We've got our cleaning stages first. They're alkaline cleaning stages, a spray and an immersion stage, followed by water rinses, usually 2, followed by a surface conditioner, which activates the metal, gets it ready for a zinc phosphate coating, which happens in the next stage. The conversion coating takes place here, followed by a water rinse, maybe 2. And some customers use what's called a post-treatment or a sealer, which gives you a little bit extra measure of corrosion protection and helps fill in any gaps that were not done, or if there were any voids in the metal or voids in the zinc phosphate coating. And finally, we go with either DI or RO water rinses. So this is fairly generic. Now, when you juxtapose that to a zirconium system, again, we're converting. We're not building it up as a new system. We're converting. The first thing we're going to see is that we have fewer chemical stages. In a zirconium system, we do not need a surface conditioner, and we do not need a post-treatment stage. So what are these stages? Well, the conditioner becomes another water rinse, and the post-treatment also becomes another water rinse. So how do we get there? Seems simple enough, right? And this certainly isn't rocket science, but it's also very important to follow steps and plan, plan, plan. We're going to talk about each of these steps individually as far as the protocol goes. So what's the first thing we're going to want to do? If we have our zinc phosphate system and we're saying, okay, at the next shutdown, at the July shutdown, we're going to convert to zirconium. The first thing you need to do, and you know, I wanted to make sure it's clear throughout this whole process, your supplier, your pre-treatment supplier is key. They should be leading a lot of this process and driving this. So what's the first thing you want to do? And I know some of these slides are a bit busy, but there's a lot of key things to cover. First thing you want to do is walk through the pretreatment system. Your supplier, your technical folks from your supplier, and your technical folks, whether they be materials engineering, paint process engineers, et cetera, at the plant. Walk through the system, both interior and exterior, and you'll stay a lot drier if you walk through the system inside when you're not running production. It's much easier that way. You need to look at everything. Now, you know, every pretreatment system engineer or operator has that wish list and said, man, this has been broke for a long time, or we need to fix this. Typically, when an OEM is converting from zinc phosphate to zirconium, there's a budget associated with that. There's money put forward to do whatever modifications are needed or fix whatever thing. Now is the time to get that stuff fixed. So on your walkthrough, you want to look at everything: the structure, the tanks, the walls, pumps and piping, the external systems, filters, heat exchangers, anything else that you can think of. A couple of things to note is zirconium process does not require those specialized sludge removal filters that zinc phosphate does. That's one of the huge advantages of zirconium. It doesn't produce sludge. Doesn't require those boil outs. So the first thing you can do if you want is ceremoniously just rip that sludge filter out that always seems to be clogging up or breaking down. What you want to do is just use standard filter kettles with filter bags. 5 micron is recommended. You can go a little bit higher if you need, or you can go down to 1 micron. So that's a huge benefit. When you're walking through the system and looking as production is running, if you can open those doors, you want to look for any drying. Drying is a big no-no. First of all, it's a big no-no with zinc phosphate, but it's even more important with zirconium. Zirconium doesn't give us quite the latitude that zinc phosphate does. So any drying is going to be an issue in the system. So that's an important fact. One other thing when you're walking through is take notice of, after it exits your zirconium stage, how long before the units get rinsed? Okay, is it 10 seconds? Is it 20 seconds? Is it 30 seconds? And the reason is because often a knockoff riser is needed at the exit of your zirconium or phosphate stage. The reason is we want to quench the reaction. Okay, the longer the distance between the exit of the zirconium stage and that first rinse stage, which is usually a spray, that reaction is continuing to react. And it's not going to continue to react evenly because it's not being replenished with fresh liquid. So it can continue to react and in different levels, causing surface conductivity differences, which the E-coat may read differently, and you can get E-coat appearance issues. So it's very likely you will need a knockoff riser in that area. Everybody good so far? Questions? Another important aspect, if you're an OEM, is looking at the body shop and the condition of the incoming metal. okay? Especially the zinc-coated substrates, electrogalvanized, hot dip galvanized, galvanneal. If there is a lot of metalworking done in the body shop, AKA sanding, then you need to take some precautions, okay? Very common to use what's called a dual action sander in the body shop. That's that spinning thing where they just kind of put it on the metal and remove imperfections in the stamped parts or even, you know, sometimes the blanks. And it creates what we call a bullseye. And sometimes if it's not done correctly, if you're just taking the dual action sander, digging it in, pulling it away and letting it go, it'll create a hard boundary between the area that's sanded down to that bare cold rolled steel and the surrounding galvanized. If there's a hard boundary layer, that can also sometimes show through the electrocoat after recoat. The proper technique is to feather it. As you're sanding, feather away from the actual middle of the bullseye so that there's not a hard steel versus galvanized boundary. That helps considerably. So all of these things are what we're going to want to look for before the conversion or before we even start the conversion. And a lot of times that's really going to the body shop and training them and educating them on what they're going to be seeing. And we all know that in OEM plants, the body shop and the paint shop cooperate completely, right? Chris, no? Yeah? Yes. Yeah, okay, all right. That was your cue, Chris. I was hoping. All right. Once that walkthrough, that audit is done, you want to start doing the launch calls or launch meetings, whatever, either in person or online. And again, the supplier should initiate that. And depending on how far away you are from the conversion, they can start out monthly or they can be as quick as weekly. We have planned brownfield conversions as far as a year ahead of time. You know, when you're that far out, a monthly call is good enough. But when you get within 6 months, 7 months, you're going to go to biweekly. And as you approach the last 8 weeks of it, you're going to need to shift it to weekly. And again, that should be led by the supplier, and the folks on there should be the supplier technical team, typically the supplier's key sales personnel. But there's got to be the right plant, the materials engineering from the customer, pretreatment operators, process engineer, maintenance manager, maybe some of the maintenance folks, certainly the wastewater treatment technician or manager. Wastewater treatment is going to be critical in this boil out and this conversion. And some of the topics, the planning dates, the quantity of the chemicals when they're going to be delivered, the layout of the pretreatment line, the parameters, the clean out and charge up Gantt, laying out hour by hour what's going to be happening, the supplier support schedule, and most importantly, and which is where you're probably going to spend most of your time, is the action item list. Okay, and that action item list is all of the things that need to be done. And I don't mean just on the system, but ordering chemicals or getting new testing equipment in. But that's where you're going to go over every meeting, all that list of things that needs to be done to the system. Who's responsible for that? Who's going to get that done? And the progress of it. That is critical to plan that ahead of time. Next, this kind of just stands on its own. I mean, really, before you're going to start the actual conversion, you need to make sure that the action item lists any modifications to the system, any new installations, if a knockoff riser is needed, if new filtration is needed, if something's different, this needs to be done before you actually start the conversion or start the clean out of the system. Next is the system cleanout. I think most of us know, and if not, I'll tell you now, zinc phosphate does not play well with zirconium. we need to make sure that all of the zinc phosphate, or as much as physically as possible, is removed before the zirconium is loaded. Too much phosphate will compete with the zirconium and inhibit the deposition of a uniform coating. Now, how thorough this cleanout will impact the performance of the system. And typically, we even measure this after we do the cleanout. We will fill that last rinse up, measure the conductivity. I'm sorry, measure the conductivity, measure the, not only the conductivity, but something I forgot to add here, the parts per million of phosphate. And ideally, it should be less than 10 parts per million, but in practicality, we've seen less than 50, and that has led to successful cleanouts. But it's important to measure the phosphate, because for all of us who've dealt with zinc phosphate, we know that sludge can build up in hidden areas and become like cement. Here is a great example of a phosphate pipe, a header pipe that is a 3-inch header pipe in a system that had not been cleaned out in 2 years. And that buildup in there is zinc phosphate sludge. It reduced the opening to about 1/2 inch. Now, at this point, even a chemical boil out is not gonna remove that. The pipes are gonna have to be removed and replaced. This is grading on the floor and filter screens in a pump well. That is caked with phosphate sludge. That's got to be removed either by the boil out, or in some cases, grates are replaced. So a lot of times grates are just pulled out, new grating pulled in. And this was a conversion we did about 2 years ago. And for the actual cleanout, it's done by the system. The first half of the system, both zinc phosphate and zirconium, is usually alkaline, because we've got our alkaline cleaners. In the case of zinc phosphate, the water rinses and the conditioner are alkaline. Starting with the zinc phosphate stage, everything after that is acidic. So the boil out, when we do a conversion, we alkaline boil out the cleaner stages, and we acid boil out the subsequent stages. And zinc phosphate and the water rinse after, those 2 stages are usually the dirtiest. And typically, nitric acid is used, although I've seen sometimes sulfuric acid, I've seen inhibited hydrochloric acid, phosphoric acid. But these boil outs, depending on how long or how bad the sludge buildup is in the phosphate bath, they can go on 24 hours, sometimes even 36 hours at temperature, 120, 130 degrees. Now, here's where waste treatment is critical. Waste treatment has to know exactly when this is happening and when stages are going to be dumped, because not only are we going to be boiling out or cleaning out these stages with chemicals, they need to be rinsed down. So typically they'll be rinsed either with a power washer or a hose. They'll be filled up with water, circulated, and dumped. So if you've got a complete phosphate system here, this could be 200,000, 300,000, 400,000 gallons of water. Waste treatment has to be lockstep with the timing. Out of every conversion that we have performed, over 90% of the delays, if there are any, are because of waste treatment is not ready to handle those volumes. So very, very critical that waste treatment be involved. How are we doing on time? Oh, actually not too bad. Now, I've got this slide or step number 5. It doesn't have to be 5, but one of the things that the supplier needs to do is provide a comprehensive training in thin film technology to the new customer, because chances are this customer in this plant and these folks have not experienced zirconium or thin film before. And again, it's not rocket science, but it's about getting used to it, okay? What the training needs to be about the technology, about the operation, what's different, what we're measuring, how we're measuring it. There's often different equipment. The importance of cleaning and degreasing, coating weight measurement. And one of the biggest things is the appearance of thin film versus zinc phosphate, okay? We all know what zinc phosphate looks like. It's that matte gray. And if you've been in the industry a lot of years, you take your fingernail and you'd scratch that zinc phosphate coating, and people would look at it and they want you to let you know how intelligent they were. Say that coating weight's about 150 milligrams per square foot. Well, you could scratch it to see if there was a coating, but a lot of times with zirconium, it doesn't look like there's a coating there. Aluminum goes in shiny, comes out shiny. You know, you cannot really see the coating. And a lot of times with cold rolled steel, you may get a bluish tint or an orangish tint, which if it were zinc phosphate, it would mean that there was a very bad coating, but it's normal with zirconium. So it's very important to manage a customer's expectations of what they're going to be seeing is different, and it doesn't mean it's bad. And that's a big thing to deal with. That next step is just load the pretreatment system with the chemicals, with the thin film chemicals. And again, you know, you're building up to this. You've been dealing with this maybe for many months, taking great detail with your meetings to go over the action items, making sure everybody's done what they're supposed to do. So we're ready to fill. We're going to fill it. Cleaner and degreaser stages, they're filled up like they always are. I mean, a cleaner and a degreaser are pretty much the same way. It may be a different cleaner with zirconium than with zinc phosphate. But as far as the first time you fill the zirconium stage after a clean out or conversion, we recommend a dummy charge. And what that is you're going to fill it up with water and you're going to add a small amount of the zirconium material to make it up, okay? And then circulate. And what that zirconium will do is if there's any phosphate, residual phosphate that's kind of roaming around in there that is loose, that will scavenge it. It'll bind to it, or the phosphate will bind to that. Dump it, hose down the walls, fill it up with water, and then build up our bath. Now, after that, it's just left to validate the pretreatment system. So you know, we've got our complete system rebuilt. We're going to do our final adjustment to adjust the chemical baths to hit the target specs that we're looking for. We're going to take bath samples to analyze the key constituents back in our laboratory, the supplier. We're going to run representative substrate panels because typically always before units are run through, the customer will run a conveyor line or run carriers through, strap a couple of panels to that, ideally with the plant substrate as opposed to standardized panels, so you can see with both. Actually, ideally do both. See if there's any variation. And then your customer's going to, whoops, I didn't want to do that. Run validation units, measure the coating weight. Another nice thing in today's world, we can use X-ray fluorescence or an XRF unit to measure the coating weight right at the customer. For those of you who have not seen it, you can get a handheld unit, looks like a police radar gun. You can stop the car, put it right up there. 30 seconds later, you have a coating weight as opposed to taking it to a lab and doing a weigh strip weigh on it. So it's very convenient. And then, just like anything else, as production ramps up, you're going to adjust your chemical metering pumps to maintain your target values and do routine bath sampling and panel processing to ensure coating weights. And ultimately, get panels painted, put them through full corrosion testing to validate the process as a whole. So, key takeaways from this, and there are a couple, but there's some more important than others. And one of them is, again, planning, and more planning. Phosphate stage absolutely must be clean. We don't want any drying prior to the thin film stage. Many systems for the conversion, we've had to add additional risers in dwell zones to keep the unit wet. Rinse quickly after the thin film stage. If a knockoff riser is required, put it in. Again, zinc phosphate is a self-limiting reaction. Most of us have seen the crystals on a zinc phosphate SEM. Once the surface is covered with those crystals and there's no more bare substrate to react with, the coating reaction shuts down. Not with zirconium. It will continue to build the longer it's in the bath or exposed to the chemicals. And comprehensive customer training. Follow-up support by supplier, that's critical, especially as you're ramping up. Especially if it's a plant that doesn't have a lot of experience with zirconium. You got to lean on your supplier and count on them to provide you that experience of what to do and what not to do as you're ramping up. Questions? Hopefully everybody's still awake? I mean,
we have some on the apps.
Okay.
So
Here's how.
How do you control the degree of etch of different substrates after switching to thin film?
Wow, that's a different topic altogether. I'll give a very quick answer. With thin film, we don't get as much etch from the actual thin film bath as we do a zinc phosphate bath. So the etch has to be really mostly provided by the alkaline cleaner, okay? Most of the time, there are different alkaline cleaners used for zirconium compared to zinc phosphate, and those cleaners will give that extra level of etch.
The second question here is, does the hardness difference between the zinc and zirconium cause any issues?
Hardness in what respect?
I believe the inherent hardness in the zinc phosphate and the zirconium.
No,
Not,
I don't believe, understanding the spirit of the question, no, I don't think there causes any issues.
okay. Pertaining to zinc phos, has chrome seal rinses been phased out by the industry?
Great question. And that goes back to the post-treatment stage that we saw up there. As far as chrome rinses, yes, chrome rinses were phased out of the automotive industry in the 90s. But post-treatments were still used and are still used on occasion. They are no longer chrome-based. They're either zirconium-based or polymer-based. And most OEMs have backed off a little bit from the use of post-treatments, with the exception if they're running aluminum in a zinc phosphate system. Typically, a post-treatment is used on those lines. Pardon me? Great question. The question is there any competition between the zirconium and the zinc phosphate? So the unit will be zinc phosphated first, okay? And then the post-treatment, again, is really designed to fill any voids or bare metal. So if the phosphate is already on there, it's gone through a couple of rinses. Typically, we don't drag a lot of phosphate into the post-treatment stage. And the phosphate bath itself, the pH of the post-treatment stage is not low enough to where it's going to etch the zinc phosphate and cause a problem.
There is a question, I think it's more of a comment here before starting the conversion. If it is funded, properly funded, do you have everything that you need to make the conversion successful?
Chris,
You said the first question you have to know is, when you start the planning phase. So the first question is the conversion properly funded? I think that's the biggest question, especially in brownfield.
Yes. Proper is a big word.
Hey, let's fix what's broken. Let's look at the pumps, the gauges, the things that aren't working now. They only become more critical once you get into the zirconium thin film. So if you don't take the time and you don't find the funds, it's just going to become a future head.
Absolutely. And to answer the question as best I can, when we start out a conversion process, we're always asked for a wish list. What do you want to do? And it's this big. And by the time the rubber meets the road, it's saying, what do you absolutely need to make this conversion successful? And the list goes down to about like this. So no, it's not always properly funded.
Could you explain why the feathering at the boundary is recommended during sanding?
I think the gradual transition from iron, steel, to introducing the thickness of the galvanized layer slowly up to I think the system reacts to that better, and the conductivity, just the coating is able to just more uniformly build there to get a more of a uniform conductivity. I'm spitballing here a little bit, but when you get pure iron going to pure galvanized, for whatever reason, the E-coat reads that differently. And I guess if I know there's some E-coat folks here. If somebody has a better explanation, please. Surface it comes down to surface conductivity.
I'll take one more question here, and oops, excuse me. Zirconium is an ambient temperature technology, but how important is temperature and humidity control in the post cleaner stages?
Great question. Increased temperature in a zirconium bath will cause the reaction to happen at a quicker pace, certainly. So you typically get higher coating weights the warmer the bath is built, or the warmer the zirconium bath is. It doesn't have a huge impact on it. The absolute largest impact on zirconium coating weight is process time. We can make some chemical adjustments. We can make some temperature adjustments and fluoride adjustments that will affect coating weight, but not nearly as much as process time. What was the last part of that about the cleaner? Sorry. I have 10-second Tom with my memory.
It was temperature and humidity.
Okay, temperature. Well, humidity is not as critical in that area as drying is. I can't stress that enough. You want the proper humidity level so that it doesn't dry. Because alkaline drying on a surface, the coating, the zirconium coating, or for that matter, zinc phosphate coating, will not deposit in a uniform way. And in some areas, if it's dry, that alkalinity that's dried on there, if it's too bad, it won't deposit it at all. And just rinsing it in a water rinse is not going to remove that dried alkalinity. If you put it in another cleaner bath, you should be okay. But just a water rinse is not going to erase that drying.
There are a couple of questions, I think, if you want to take a look at the app and answer those.
Very good.
For sake of time management.